we have recall that we have 1 plus x squared of the second derivative, and the second derivative is given as thus. We got our second derivative as summation r start from 2 to infinity of r minus 1 ar x r minus 2, then minus 4x, then y prime is what we have as summation y prime r start from 1 to infinity of ar x r minus 1. Then finally with plus 6y, y is summation r start from 0 to infinity of ar xr equals 0. Now considering this, we can decide to simplify this further. So first thing we need to do is we have to open up this bracket that we have here, this. If one multiply this summation, then I will have summation r start from 2 to infinity of r minus 1 of ar xr minus 2. Then if x squared multiply this summation, I will end up having plus x squared times this. Remember, this x squared goes inside, then it's multiplied this. I will end up having x raised to the power of 2 plus r minus 2, and I will end up having summation of r start from 2 to infinity of r minus 1 ar, then I have x raised to the power of r. Do you agree with that? Yes, there's nothing wrong with this. It's correct. And then similarly for this 4x, by the time this 4x go inside the summation, we will end up having summation as when r start from 1 to infinity. Then I have 4. If this x multiply this xr minus 1, we all believe that we end up having ar xr, right? And then this 6 go inside the summation, we end up having summation r start from 0 to infinity of 6ar xr equals 0. Now, since we have this, we need to follow some steps here in this case, such that I have two things to consider. I'll consider their limits, and I'll consider the power on the variable I have here. The variable x, the power I have on this variable is r minus 2. Here I have it to be r. So since this is x is power of r, x is power of r, x is power of r, I need to express this in terms of x is power of r. And how will I be able to do that? So suppose I decide to set r to be equals to this r I have here to be equals to r plus 2. Set r to be equals to r plus 2, then it affects everything we have here. So here I will end up having summation. By the time you set this r to be r plus 2, you have equals to 2. Wherever you see r, just put r plus 2. Wherever you see this r, put r plus 2. Then here I will be having r plus 2, then minus 1, right? And here in this case, I will be having this r here becomes r plus 2 x. R minus 2 here becomes r plus 2 minus 2. Done. So now I don't have any business with, since this is my target, I want this xr minus 2 to become xr, and it is successful. Because if this cancels this, I have just ordinary xr. Then everything, all the variables are common. So I can easily factor out. But I can only factor out if all their limits are also the same. So that's not a problem. So let's just try this out. Then we have summation r start from 2 to infinity of r minus 1. I don't have any business with this. I just have to repeat it. Minus summation r start from 1 to infinity of 4r. I have ar xr plus summation of r start from 0 to infinity of 6ar xr equals 0. Now since I have xr common to all the terms, but here in this case I have r plus 2 equals to 2. Let me consider the limit itself. The limit for the summation, I have whatever I have here is r equals 2 goes to the other side. I have r start from 0 to infinity. Then here in this case I'll end up having r plus 2, then r plus 1. Plus 2 minus 1, that's plus 1.